Good morning, good afternoon, good evening, wherever you may be watching this video from. This is Cornelius Dubinda with another video. And in the previous video, the video was cut short because I wanted us to actually think about what I said. So as you can see, we ended on question E, which reads, they wanted us to find the distance traveled in the first 3 seconds for this particle given that displacement function. Now, what does displacement function do? It will help you find the displacement. That is why when you see here, when we integrate from 0 to 3 here, okay, as you can see right there, the final answer we found was a -6 meters, which is actually close, but it's not the actual answer. The approach we're supposed to use is one like this. So we were supposed to say S1, which is the first distance, is equal to, first of all, okay, before I even say this, let us first of all say V is equal to 0. When is V equal to 0? We already calculated this and we said T is equal to 2.5. Now we need to know that when a particle is at instantaneous rest, the direction will reverse. So what were we supposed to do? We were supposed to integrate first of all to find S1. It's equal to the integral of velocity function from 0 seconds to 2.5 seconds with respect to t plus S2. Okay, let's just leave it like that. So this is our S1. Then it's equal to the integral from 0 to 2.5, like that. And then our velocity function is the 2t, or rather, what was it? It was, yes, it was a 2t minus 5, like that. So I'm going to substitute with a 2t minus 5 dt. This is going to become is equal to, when you integrate, t squared minus 5t, and this is going from 0 to 2.5. Again, you will say is equal to, if you substitute the 2.5, it will be 2.5 squared minus 5 multiplied by 2.5, then minus 0, like that. 2.5 squared, you can calculate this by yourself, or you can use a calculator. It is equal to 6.25. Then 5 multiplied by 2.5, same as 25 times 5, so it's 125. So it's minus 12.5. We are going to have S1. Sorry for that. Sorry, S1 is, so S1 is equal to a negative, because of following the sign of the bigger number, negative 6.25 meters. So that was our S1, negative 6.25 meters. And then we integrate from, so I'm going to say S2 is going to be equal to the integral from 2.5, right? 2.5 to 3 seconds. Why can't we integrate from 0 to 3 seconds directly? Because there is instantaneous rest within this journey. So you have your velocity function 2t minus 5 with respect to t dt. Okay, if you integrate that nicely, t squared minus 5t from 2.5 to 3. So this will be equal to, square bracket there, 3 squared minus 5 multiplied by 3 minus 2.5, like that, minus 2.5 squared minus 5 multiplied by 2.5, like that, close the square bracket, Then if you simplify nicely, you're going to have is equal to so let's put a comma here so I don't get confused. So you're going to have is equal to a what? 3 squared is 9 minus, this is a 3 here, just take note it's a 3, so 9 minus 15, which we can just simplify, right, to create more space. So take note this is a 3, so 9 minus 5 times 3, which is negative 6, then minus, here we're going to have 2.5 squared. 2.5 squared is going to give you 6.25, then minus, this is a 2.5 here also, sorry for that, 2.5 minus a 5 multiplied by a 2.5, so it's 6 minus a 12.5, so it's 6.25 minus 12.5, you're going to have a negative 6.25, and then you're going to have is equal to a negative 6 plus positive 6.25. So you say S2 is equal to a positive 0.25 meters. Okay, so here at the negative 6.25, here at the 0.25. Now another funny thing is that when you're using this method, you take the modulus, okay? You take the modulus. So every value you find, you take the modulus of that value. So for S1, it means if you take the modulus of S1, S1 will be equal to a what? 6.25. So 6.25 meters. And then S2 will be equal to a what? A 0.25 meters. And then S will be equal to S1 plus S2, which is equal to 6.25 plus 0.25, and then finally S will be equal to a what? A 6.50 meters. This is the distance traveled in the first 3 seconds. You can't find the negative value for distance because distance does not is not affected by direction. It is a scalar quantity. That's why we do this. So you have your negative 6, your positive 6.50 meters, like that. So this marks the end of the video. This is what I wanted us to just think about. So we'll practice some questions on the same, just trying to show you where people get it wrong, because the negative 6 we found here is why it's coming about as a result of having values like so let me just write it down. Let me just write it here. Values like what? So values like this. So you have your S1 being equal to negative, let me show you, for example, let me do it like this. So I have a negative 6.25 as your S1 plus your S2 is a 0.25. So if you are to add these the way they are, you're going to have a negative 6 meters. And this answer is not bad. It's close to the final answer. But actually you're answering a different question. Actually this answer you would find is actually the displacement. So the displacement takes into consideration of the direction. That's why you have a negative 6 meters. Distance, you can't have a negative. Thank you so much for watching this video. This has been Connected with another video, and bye bye.